So now we're going to look at retirement. All right. So when we're doing calculations for retirement, we might use both the savings annuity formula and the loan or payout annuity formula. And the reason for that is that as we're saving, as we're putting money away for retirement, we're using this saving annuity formula. But if we want to figure out, once we've got our money saved, what we can get on a monthly basis for our retirement, that's being paid out of an account. That's the payout annuity formula. So we may use both formulas in a retirement problem. All right, so let's look at an example. We want to have $500,000 when we retire. Our retirement account pays 4.5% interest, compounded monthly, and we start the account when we're 22 years old and plan to retire at 60 years old. What amount do we need to deposit each month to reach that $500,000? Now, that is, we're saving, we're putting away for the future. So we're going to use the savings annuity formula, and I brought that down here. Let's identify what everything is, though. The $500,000 is the future value. It's our PN. So let me get my draw feature going. This is P sub N. It pays 4.5% interest. So as a decimal, that's 0.045. And that is R. We're going to compound monthly. So that's K. 12 times per year. And we start the account at 22. We're going to retire at 60. That's 38 years. So N is 38. It's a good number of years for retirement. All right, so let's see how much we're going to need to deposit every month for 38 years. Okay, so P sub N we said was 500,000. So let's put that on the left. We don't know the amount we're going to deposit. That's what we're trying to figure out. So let's leave that alone. And then we have 1 plus R is 0.045. K is 12. Raised to the 38 times 12. All right, minus 1. All over 0.045 again, divided by 12. Okay, so let's work our way through. Now, before doing anything with the equal sign, I want to break down all of these parentheses. So I've got 500,000. And D. Let's do the inner set of parentheses first. So 1 plus 0.045 over 12. I'm going to do that calculation in my calculator first. And I end up getting 1.00375. And now it's very important that I do the 38 times 12 before I do my power. So 38 times 12 is 456. So this is now to the 456th power minus 1. And then on the bottom, remember that this right here really ends up being just the decimal without the 1. So it's 0.00375. And I better give myself some more room here. Well, I didn't mean to quite do that. Let's see if I can do it like that. Okay. Okay, now let's continue with our calculation. We have $500,000 over here. D. And now I'm going to put 1.00375 raised to the 456 in my calculator. I get 5.511 306686. Just make sure that's right before we go on here, that I have not looked at that wrong. Nope, okay. And all of that over 0.00375. All right, now let's continue with our calculations. I've got 500,000 D, and I'm going to go ahead and subtract this minus 1, which is really 4.511306686. Didn't mean to go through that, but... And then let's do that division there. Let's divide the 4.511306686 by the bottom. And we'll be ready to solve this equation. All right, so it's supposed to be my D right there. All right, so if I put 4.511306686 divided by 0.00375, I get 1203.015116. 015116. Now let's notice that I have something being multiplied times D. So all I need to do to solve for D is divide out that something that's being multiplied on both sides, of course. So I'll divide this side by this ugly decimal, and I'll divide this side by this decimal. And let's see what we get. Now, I'll go ahead and round this off. $415.62. Now, that may seem like a lot, but the truth is most of the time you don't even see that money. It's taken out of the check before you get your check. And many times your employer is also in some way matching it or giving you a percentage of that amount of retirement. All right, now, so we found out we've got to deposit $415.62 a month in order to have $500,000 in 38 years. Now let's look at, we've got our $500,000, we're 60 years old, we're ready to retire, assuming that we live for 25 years beyond our retirement. So we live to be 85. And we may base this on the fact that the other people in our family have lived about that long. What can we draw from this account each month? How much money can we get out? And our interest rate remains 4.5% interest yearly. So in this case, we are taking money out of the account. So the account is losing money. So we need to do a payout annuity formula. And I'll go ahead and cut and paste that. So let's identify everything that we've got. The $500,000 is the initial amount in our account, and that is going to go right here for P0. So our initial amount is $500,000. And we're going to have 25 years worth. Hopefully, there's our in. We're going to withdraw every month, so K is 12. And we'll assume that it's compounding every month as well. And our interest rate is 0.045. All right, so let's do this. So we'll have 500,000 equals whatever that withdrawal is going to be, 1 minus 1 plus 0.045 over 12 raised to the negative 25 times 12. And all of that goes over 0.045 over 12. All right, now since these are the same numbers we had up here, let's cheat just a little bit. 1 plus 0.045 over 12 actually is up here, and it is 1.00375. So we'll just cheat a little bit. So what we have is 1 minus 1.00375. And let's put negative 25 times 12 into our calculator and see what that exponent is. Negative 300. And over, and remember we can get this from this little bitty piece behind the 1, 0.00375. Then let's continue. And I will now put 1.00375 to the negative 300 in my calculator. So that ends up being 0.325336291. And now I'll subtract that from 1. And now I have 0.674663769. I'm going to go ahead and divide that by the 0.0035, and then I'll be able to solve this equation. So that ends up being 192.761057. And then my last step in order to find D is to divide that on out and get D by itself. And I'm running out of space. Let's see. No, I've got space. So we'll divide that out on both sides. And we get 25.93. And we'll go to cents here, 88 cents. So that may not seem like very much money a month, and it's not, which is why most people who are retired are on a fixed budget. Now, usually they have paid off their house and many of their bills by the point they retire, so it's possible to live on this amount.